Morning, Chem students. We're going to chat a little bit about modeling this morning. And to get us started, I have this short little video we're going to watch about the practice of developing and using models because it's important to science.
Hi, it's Paul Anderson, and this is Science and Engineering Practice 2, Developing and Using Models. Models are important in science and engineering for a couple of different ways. In science, we use models and modeling to explain phenomena or to share an understanding of how the world works. In engineering, we use it to analyze systems, and lots of times we'll do simulations or build models to see how a design is going to perform.
Let's back this up just a second. There we go. All right, so to explain phenomena and analyze systems, that's one reason that we study models. They're really important in science because oftentimes we're talking about things that we can't maybe see just in one moment. For example, maybe in grade school you saw something like this. A model of the water cycle, okay? So we might know, like, oh, of course it rains, but we can't see this whole image in one moment. Like, it's not really very possible for us to see all of this in one vantage point. We might just see the rain, for example, but we don't know, oh, it's going to go down the river and end up into the ocean or Lake Michigan and then evaporate and become the clouds, okay? So we make models of things to explain a phenomenon, explain something that happens, and then also we use it to analyze systems in engineering, okay? Let's bring you back to last year in biology, and here's just some examples of models. I think you guys made books, rather, about cells. So this is just an animal cell. You got your mitochondria, those powerhouses. You got your nucleus, your Golgi complex, all those good things. But this is a model, okay? So we can't, like with our naked eye, really zoom in necessarily without a microscope and see this thing right here, this cell. But if we make a model of it, we can talk about it. We can talk about what's in it. We can see how they're related to one another, okay? How this cell wall here is protecting everything that's inside. Another way to make a model might not be a drawing, but maybe this person got creative and they took some objects. They took a box and, I don't know, like a mouse and whatnot, and they kind of said, like, this represents the nucleus, or this represents, what's this box? The Golgi bodies? I don't know. So they had a reason for it, but they made this model, okay? In chemistry, and generally in science, great models are always going to include these things. Different parts, clear labels, lines, arrows, or symbols to show relationships. How are things connected? A key, and then specifically for chemistry, we want to include these changes or flows of matter, matter being particles, and energy. So let's do a quick example. That'll hopefully, can I make this move? Can't. All right, so I'm going to draw over here. All right, so let's try to keep these great models in mind. And maybe we could just really quick look at this one. So let's just assess, is this a great model? We have different parts here. Obviously, let me choose a different color. So different parts. There's the cloud. There's the lake. There's also what's actually going on, the precipitation, the transpiration. So it's clearly labeled, right? Like we can clearly see what each component is. And so on. We have these lines or arrows that kind of show relationships. So we see sort of this water cycle. It starts here, comes over here, it keeps going. This is our cycle. So we can kind of see the connection, the flow. It doesn't include a key. It doesn't really include a key to let us know that, like, these little things, these little blue arrows are the water. So maybe that would be helpful. Maybe we'd want a little key over here. It says blue arrows equals water, so we could know that's how the water is cycling through. And then finally, this isn't necessarily a chemistry model, so it doesn't do this, the changes or flows of matter, particles, and energy. So let me demonstrate that for you. Get black here. Okay, so let's come over here. Let's imagine a pot of water. You got it under a source of heat, and there's some water in here, and it's making some steam because it's boiling, okay? So that's what we see. That's what you see with your naked eye, and now we want to model what's actually happening. And we could come in here and do some work, like say, all right, blue color equals water, red color equals heat or fire, right? Okay, so we could do some work to add labels to this. We could say this is let me try to write this. This is a boiling pot of water, all right? So I've included some labels. Don't really have many things yet to show connections, but let's try to zoom in. Let's imagine we could take this image and make it way bigger, okay? So I think, oh, nope, I didn't want to do that. Undo that. Let's just come to the side. Let's just come over here. So let's zoom in. So let's take this image and make it bigger, okay, as though we zoomed in. So now here's my pot, here's my water, my heat source, and I want to add the particles. So I've hit most of these things, right? Like I had my key, I did my lines, my clear labels, my different parts, but here, changes or flows of matter, anything that has mass and takes up space, those are the particles and energy. So we want to imagine we can zoom in and say, what's going on with the little waters in here? Why are they going from a liquid to this steam, to a gas, okay? So if I imagine my little particles of water, just draw them in here. Obviously there's a ton of them, but I'm just adding some. So they're hanging out in here, right? Added my particles. These are my ones that are liquid. But I also want to show how they're moving. So they're kind of moving back and forth. So I'm going to actually add some arrows here to show some movement. All right, so they're moving around. Got some movement. Goodness, I drew too many particles. All right, so those are the ones that are in the liquid water. But then there's that steam, right? And I can draw the steam in, but I also want to know like what's happening as far as the particles. Why are they becoming a gas? And one thing we'll talk about more in chemistry is that as things get hotter, they gain more energy and they can change states. So this is a liquid. Liquid water. Water is hydrogen and oxygen, H2O. This is a gas, H2O. We call this steam. Okay, and these water are much further apart. They got a lot more space between them and they're moving really quick. So I'm going to draw a long arrow to show that they're flying around. They got a lot more energy than their friends who are stuck in the liquid because they heat it up. So the last thing I want to add is some energy. And I'm just going to say that my little yellow color, I'll add it to my key. My yellow equals energy. And I'm going to say that there's energy coming from the heat source going up, and it's going to be connecting here to the, it's going to be adding energy to my liquid water, and then the energy just increases, okay? So the energy is then transferred to these steam, these gas particles that are really moving a lot quicker. So let me just add one more thing to my key. I'm going to say that this equals H2O particle. And now, I've showed some connection. I've showed how the energy, sorry, wrong color. Showed how the energy is flowing. It's coming from the heat source. It's going into the water and then into the gas water, the steam. I've included here that these are particles. And then I've also shown that the blue is water and the red is heat. So that is one way to model. And so you'll do something like that in a moment. Feel free to pause the video now and be done, but real quick, if you want to see for the initial modeling, this is where you're going to come in and say, where do you think the water is coming from to cause sea level rise? Answer this next question. This first model here is going to ask you just to model why the sea level is rising all around the world, and you need to include these things. Different components or parts, lines or arrows or symbols that show relationships between them, and a key that shows what any colors or symbols mean. So you can draw it maybe here, maybe put your little key on the paper over here and say like what maybe the symbols or the colors represent, okay? And then on the back side, we're going to take it that next level, and you're going to go to the particle level. Let's make my part, there we go. So down to the particle, this is not what I needed. I wanted to do this one perhaps. Either way, the particle level. I'm struggling to get my little marker small enough here, guys. The particle level. So I want to include the particles like we did right over there. All right, and then kind of talk me through like why you included the components you did. And then finally, we'll practice it one more time right here. This is our mastery check. And I know mastery checks are new, but this is that exact same question. You're going to draw a model to show what you think is happening, specifically at the particle level to cause sea levels to rise. Show me any changes or flows of matter, particles, and energy. And then include those things right here. And you can kind of see how your mastery check will be graded. Basically, you got to get a 4 or 5 to show me you've mastered it. If not, it'll mean a retake, which means you'll say, hey, go back and watch this video again. Or, hey, let's kind of check in. This looks like you're pretty close. We're just missing a few things here. So that's what I got for you all. I hope you have a wonderful day. Don't forget that you matter.